So basically, I have this backpack here. It has 4 potentiometers. One right here, one right here, one right here, and then one right here. And then I have an Arduino Mega right here, and the Bluetooth module right here. The Bluetooth module sends the data to this Bluetooth module, which is connected to an Arduino Uno, which I plug into the computer, and which means that it's wireless. And then right here I have 4 potentiometers, which get recorded by the Arduino Mega, and they get converted from an angle from 0 to 270 degrees. And that's basically it. It's pretty similar to the backpack from the robot backpack from the robot thingy video. All the orange parts are 3D printed, which took a while, but it finally worked. Yeah, I had a lot of failed prints as well, which I had to reprint. And there are like a lot more, but I pretty much threw them away. And I used Onshape to 3D print all my parts. I designed it on Onshape. I highly recommend it. It's free for students. And yeah, I used it to design all my parts. And then I 3D printed it using the Cura. I converted it into an STL file using the Cura for the printer. Alright, so it's time for the code. This code is for the VR backpack thingy. I still don't know what to call it, so I'm just calling it VR backpack. Alright, so let's get started. Here we're just declaring the variables, and you might notice there are 2 sets of variables. I have 2 sets of variables to compare, and I'll get into that a bit later. And here we're just setting the baud rate of 9600. And here we're just storing, reading the analog input on the t variables. I didn't know what to call them, so I just put a t at the end. Yeah. Alright, we're just reading the analog inputs on the t values, and then I have a delay of 15 milliseconds, and then we're reading it again on the normal values, and then we're mapping both of the values to 270. And the reason I do this is because the original values from the raw values from the potentiometers were a lot messy, because they would like change very often. Like they would go to 81 to 80 to 81 to 80 to 81, even if the potentiometer wasn't doing anything. So this is just to prevent that, so there's no shaking on the game thing. Right here is, as you can see, if the difference between them is less than 2 or greater than -2, then it stays the same. And if it's more than 2 or less than -2, then the new values get assigned. And here we're just printing the analog values to the serial, so the other Arduino Uno can read it from using Bluetooth, and I just have to deliver 10 to prevent overflow of the data. So you may notice that the VR backpack and the Bluetooth thing is very similar to the last video I did where I built a robot. And it's basically the same concept, except I'm just using the data for the game, so I can just play the game. And then you might, if you watch the robot video thing, you might notice that the robot was shaking a lot, and it was because I didn't put this filter here, so to prevent them from the bells being messy. So now I put it here, and that's why it is a lot less shakier. There's still a bit of shake in the game, you may notice. It's because of the power supply. I'm powering it on a single 9-volt battery. And yeah. Alright, this code is for the receiver thing that you just plug into your computer, so it receives the data. And I'm just gonna explain the code really quickly. Here we're just declaring the array which the raw data will be stored in. Here we're just declaring the variables and here we're just setting the baud rate to 9600. And here we're just checking if there's new data. And then here we're just declaring the start markers and end markers, so we can actually know when the data starts and when it ends. We're also just mess things up. And here if there is new data, then we're reading it on char-c to check if there's any we're checking for like commas and markers, so that we know when the data is when to split the data. And here we're just splitting the data, and then we're turning it into an int so we can actually use them for the values. And here we're just printing into the serial with a delay of 1 so that Unity can read it. Alright, now it's time to basically explain the game, which took forever to make because of bugs and stuff. Alright, so let's start off with the blocks things that you hit the targets right there. So originally I had red and blue, but then I could only make for one arm, so I just switched all of them to blue. Here we just have 1, 2, 3, 5 blue block things, and then on here I have a collision hit script to make it detect when it gets hit and to make it move, and basically start the particle system. I have a particle system on there, and I have a rigid body and a box collider and is trigger. Alright, this is the script for the target block things. Here I'm just declaring all the variables and the rigid body, the particle system, the audio, and the box collider. And here I'm just assigning them to each other, the name. Alright, so I have a void on trigger enter here to detect when it collides with something, and I just have if collider the game object its name is blue Saber, then blue equals true and start quarantine. And then else if game object dot name equals wall, then red miss equals true, start quarantine. And then if blue equals true from right there, then the system is gonna play, which is the particle system, the blue effects. The audio is gonna play, you know the slice audio, and then right here it's gonna set the collision detection to false, and then it's gonna wait for 0.2 seconds so that it can finish playing the particles, and then it's gonna transform the position to a random to the random range of x from negative 0.4 to positive 4. That's the x value, and the y value is gonna be 1.5 from 2, and the z position is gonna be 40 plus transform dot position plus z. And then we set blue to false, and then we set code is triggered back to true, that we set false over here. And then here if red miss equals true, then code is triggered is false, and then we wait for 0.2 seconds. And I don't have the audio or the particle playing because you missed basically. And here we're just doing the same thing, transforming it, and then here we're just rotating it from random from either 90 degrees, 180 degrees, 270 degrees, or 360 degrees on the x value. And then we're setting red miss back to false and is trigger back to true. And here we're just we're getting the score from we're accessing the variable numbered from blue Saber. And here we're setting the act equals score, and then we're setting move speed equals to score multiplied by 0.10f plus 14, which basically means the starting speed of the blocks is 14, and then every time you hit a block the score it increases by 0.10. And then here we're just setting if move speed is greater than 20. We don't want it to go over 20.5 because it'd be way too fast. And then here we're just setting the high score. And here we're just moving the block forward using move speed, or b dot move position transform dot position equals plus move. Right, that's it for the blocks, and then I have like 5 other scripts. Alright, this is the script for the Saber thing, you know, the sword. Here we're just declaring the rebels. And then here we just setting another on trigger enter collider, and if it collides with blue, which is the name of the blocks, then combo equals combo plus 1 and score equals this variable is for score, and I just named it numbered for some weird reason. I score plus 1 and combo plus 1, and then lead equals true. This is for the lights, but I'm not using it anymore. And then we're just setting here if it collides with cube, it's the bottom part of the blocks, then combo equals 0. Alright, now here I just have a simple script for the lights in the background. Here we're just declaring the rebels, and the light is the component on the, so it's what make the lights glow. And here I'm just setting if x is less than 60, then x, just add 1 to x, and if x is greater than or equals to 60, then x equals 0, and light dot enabled. And we're just setting it to opposite. If it's enabled, then it's disabled. If it's disabled, then enabled. And this happens like once every frame, so every second the lights turn on and turn off. Now it's time for the Arduino. This is what here I have a using system I ports. This is to communicate with the Arduino, and here I'm just setting the variables and a rigid body, and here I'm just declaring the serial port, and I'm calling it data. It's on COM4 and has a baud rate of 9600. And here we're just opening the data stream, and here just declaring the rigid body. This is on the shoulder, so it's X and Y of the shoulder. Right. Here I have an array which gets a split, which gets split by the comma, and then I turn that string into an int right here into the parse. Each of the 0, 1, 2, and 3 gets turned into the int. And here I'm just declaring it for debugging and stuff. And here I'm just setting the angle, so the RSX value is the X, and here I just added 20 for calibrating because it was going to up and low, and here this is for the Z value, which is the left and right, and this is the up and down of the shoulder. And then I have this script on the elbow. Here I just declared some variables, the rigid body, and a public transform, which is right on the center of the elbow. And here I'm just getting I'm accessing the Arduino script and getting these variables from there. And I'm just rotating it, and then I'm just setting the rotation to the same. I'm just changing the X rotation by ESY, and here I'm doing the side to side motion of your arm. This was a little tricky to get, but I finally figured it out. It took forever to do. And then the last is this for the score and stuff, you know, the combo and score. This just prints it to the thing, and here we're just declaring the variables, and here we're just finding the variables, and we're just printing it to this. If you can, we're printing the values to the screen right here, combo and score. Alright, so basically the code I explained, it just gets the Arduino values of the potentiometer, and then it just sets this model of an arm, which is poorly made, to the angle. Right here I have a shoulder, and then the X value makes it go up and down, and then right to left. If that, and then there's the elbow, which goes up, and then right to left with the shoulder. And then it also goes the Y value for the rotations, the 4 potentiometers. And that's basically it for the game. And then I just press play here, and then I can play. Let me just set the mesh render off. So we cannot see it. Alright, that's basically it.